Okay, well, happy Friday, everybody. It's the end of your first week, and I hope your first week is going okay. I know it's a little bit, the first week can always kind of feel a little bit hectic, just because things are, and we've got all of these changes going on. It's online and Canvas and all sorts of stuff. And so anyway, I hope you guys are doing well. Let's take a look at today's lecture. Today's lecture is titled Subsetting. And I think, this is going to be a review for a lot of you, but we'll get into some of the nitty-gritty details of subsetting, which is going to be a very important thing that we are able to do when we're working in R. So number one, we'll just talk about subsetting atomic vectors, right? And so here I've got this basic vector type double, okay? It's got 4 values, and I wrote 2.1, 4.2, 3.3, and 5.4. And these numbers are in the 0.1, 0.2, 0.3, and 0.4 indicates that this was originally in the first position, second position, third position, fourth position, without it just being 1, 2, 3, 4, where it's already in order from least to greatest. So these are not in order from least to greatest, but the 0.1, 0.2, 0.3, 0.4 are there, so you can kind of see what their original position were in the vector, okay? And so there's a few ways we can subset, right? And I think we're familiar with some of these ways already. So we can subset using integers. So you can say, I want the third value and the first value. So you use single square brackets, right? So the subset of vector, we use single square brackets. So I've got X single square brackets, and I say I want the third and first values in the third and first position. And indeed, I get the value in the third position, 3.3, the value in the first position, 2.1, okay? Here I can ask for this function order X, and this is what this returns is it returns the index positions that would be necessary to put the vector in order. So here it says to put it in order, you would use the first value, then the third, then the second, then the fourth. And if I subset X using order X, indeed it puts it in order from least to greatest. So order is not sort, okay? Sort would return this, okay? Return 2.1, 3.3, 4.2, and 5.4. Order tells us what are the index positions that I would need if I wanted to place them in order. Okay, when you subset, you can use the same index. You can say, I want the first value, I want the first value, I want the first value again and again and again. And R has no problem. It's not like once R gives you the first value, it takes it out and it can't return it anymore. So here I say subset 1, 1 with combine 1, 1, and it gives me back 2.1 there twice. Okay. When you subset using numbers, it's expecting integers. And so if you give it anything other than an integer, it just gets truncated to an integer. So 2.1 just gets truncated to 2, and it gives us the value in the second position, 4.2. 2.9 gets truncated. Again, it's not rounded off to 3 or something. It gets truncated to 2, and it gives us the value in the second position. These are just kind of weird things. This is not something you would normally do intentionally. You normally, when you subset, you don't intentionally put in 2.9, but you might be doing some kind of math operation. And you think, all right, we're going to do this division thing, and we're going to get 3, and we're going to subset based on that. Now, later on, we'll learn floating point math. And sometimes you think you're getting 3, but you're actually getting 2.999. And it could lead to wonky results, okay? So just be aware of that. You can take whatever integers that you want, and you can put a negative sign in front of it, a minus sign in front of it, and this will tell R, I want everything except the third value and first value, okay? So I don't want the third value and the first value. And this is often handy if you kind of want to create complementary parts, right? So you're going to say, these are the indexes I want to put in the test set, and everything else I want in the training set. And so you can take your test indexes and just put a minus sign in front of it, and it will give you everything that's not part of that, right? So now you have these complementary components, right? You got one set and then everything but those things. So you can do the minus sign, okay? You're not allowed to mix negative and positive and negative integers just because it's ambiguous and confusing, right? So this is like, I don't want the first, but I do want the second. Well, why don't you just tell me you just want the second? So it doesn't know what it should do with the third and the fourth values. Do you want those? Do you not want those? So you can't mix negative and positive subscripts there. You'll get an error. Okay. A logical vector can be used to subset a vector, and basically values that are in the same position as true will get returned. Values that are in the position of false will not be will be excluded. So here, if I subset this true, true, false, false, it's going to give me back the values in the true positions. So 2.1 and 4.2. Here I have a conditional statement, x greater than 3. Okay, I have I guess a logical statement, and we're going to just ask, hey, which values are x greater than 3? So it's going to be false for 2.1 and true for the other 3, and so we get back those values. All right, I think this is fine and comfortable with everybody, right? Like we're kind of accustomed to seeing this. Let me go ahead and give you your first view quiz answer for today. Today's first view quiz answer is the letter B, B as in bear, B as in bear. Okay, so recycling applies here as well. So here I'm going to subset x using the vector true comma false, and this will get recycled. All right, and so here we get 2.1 is returned, 4.2 is associated with false, so it's not, and then it recycles true for 3.3, false for 5.4, and we get 2.1 and 3.3. So it's the same as going true, false, true, false. If you mix in a missing value, an NA, okay, then you're going to get back an NA for that thing, right? So here I got true, true, NA, false. So I'm going to get 2.1, 4.2, NA, 5.4 is false, so it doesn't get returned. So I get 2.1, 4.2, and NA, okay? Or if I do true comma NA, the recycling rules still apply, so it's going to give me 2.1 NA, 3.3 NA, and that's what we get there. So trying to subset with an NA will always return an NA or produce an NA. If you put nothing inside the subset, it's going to return everything. It's going to return the entire vector. It's generally not useful for vectors, but for a matrix, it's very useful, except especially because you might want the entire row or the entire column. So so often you will leave it blank before or after the comma for a matrix. Okay, and then if you try to subset with a 0, it's going to return a 0 length vector, which is kind of like almost like a null, but it's not. Okay, it means that there is a type. There is a numeric type here. X is a numeric vector, and it's going to say what we have is a numeric vector of length 0. So it's kind of like I'm ready to accept stuff, right? Except I just don't have anything yet to show you. It's a 0 length numeric vector. It's just an empty box right now. One thing about R is you can name the elements in your vector. Okay, so you can provide names to the vector. And then once you have names, you can then use those names to subset it. Okay, if you're accustomed to Python and stuff, it feels a little bit like a dictionary, but again, it's not exactly that. We don't have a direct data structure that's exactly the same as the dictionary. There's similarities with differences. So anyway, here we're going to take X, which again is this vector 2, 1, 4, 2, 3, 3, 5, 4. And I'm going to create a new vector Y. And all we're going to do is we're going to add names to X. Okay. And we're going to just take the first 4 letters, A, B, C, D. So the first value becomes A and the second becomes B, C, and D. So these are the names up here and these are the values. And I can then say, okay, give me back values with the names D, C, and A. And I get those. I get 5, 4, 3, 3, and 2, 1. I get exactly those values in this order, D, C, and A. And just like integer indexes, you can repeat them. So I have A, and I get 2.1 3 times. Okay. When you subset with single square bracket, the name has to be spelled exactly the same. So one way you can create names is you can just create them directly as you are creating your vector. So here I'm going to say create a vector length 2. The value 1 gets the name ABC. The value 2 gets the name DEF. And then I say, well, give me the value A and the value D. Okay, it's going to say why those names don't exist. I only have the name ABC and I only have the name DEF. So it's going to give me back nothing. All right. Is that okay? So one useful application with this subsetting business is that you can do a lookup table. Okay. So for example, here I have a vector. All right, I've got M, F, U, F, F, M, M. And somebody might say, oh, why didn't I need to put quotes in there? I could put quotes, but you don't have to. When you're creating names in a vector, you don't have to put quotes in there for that. Okay, so anyway, here, so I've got this vector and I've got another vector, which I'm going to name. M is equal to male, F equal to female, U equal to NA. So here, this is a length 3 vector, but it's named. And what I can do is I can subset, quote unquote, subset the labeled vector, which is actually only length 3, with the kind of the input X, which is length 1, 2, 3, 4, 5, 6, 7, 7 values here. Okay. And so, and what this is going to do is it's going to say, okay, we're going to find the M and the F and the U and all of this stuff here. And it then basically creates kind of a lookup table. So here are kind of the codes, the shortened versions of this. And so you can just imagine, I don't know, something like an abbreviated airlines table or something. So in the airlines data set, it will have abbreviations where it'll say like UA stands for United Airlines and DL stands for Delta Airlines and AA stands for American Airlines. And you've got all of these different airline codes and maybe you don't remember exactly which of these things are. You can kind of create a lookup table where it's going to kind of quickly tell you what the expanded version is. Okay, so the M, F, and U come back as male, female, NA or something. All right, and then if you want to kind of clean it up, you can then unname this vector, the result, right, and it'll get rid of this top row of names. And we've got that. Okay. So without the quotes, does the ABC get stored as a string? So it gets stored as names. They become part of the names attribute in. So here, let me just kind of show you what happens. We got a lot of questions about names here. So let's see. Let's text a little bit bigger. All right. So here is, we've got this, and I can can do this as well. Okay. All right, so now it looks like this, right? And I can say type of, what is type of X? Type of X is type double. The values being stored are double type 1 and 2, right? I can ask what are the attributes of X, okay? The attributes of X, there's names. Names are stored. Those names are stored as strings, okay? The names are stored as strings, but the values, as far as X goes, are type double. Does that kind of make sense? What's going on? And so the names get stored as attributes associated with the vector X. So here I can do y is 1 through 10, okay? What is y? Y is this, type of y is this, right? And then we can do something like, right now, what are the attributes of y? There's nothing. There's no attributes of y. Okay. I can do the attributes of y name. I'm sorry, names will be vector C, D, K, A, any of these things. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So now these are the names of y, right? And then if I said, all right, give me a D, it gives me back that. If I say give me back A, it only gives you the first one, all right? So like that, okay? If we mix data types for the names, yes, they would get coerced. Right? So they would get, right. Okay, let's talk about subsetting a list. So yeah, the names are just stored as a vector inside the attributes. So if you gave it different data types, it would get coerced to get stored as a vector that goes inside that attributes list. All right, if we got lists, the subsetting works similarly to subsetting an atomic vector, okay? But one thing to remember is that if you use a single square bracket on a list, the object it returns will always be a list. It's always it's going to be the same type of the original thing. So if the original thing is a list and you use a single square bracket, even if you're only getting one thing, it's still going to be a list type. Okay. If you want to get the contents of that list, then you use double square bracket or a $sign. Okay. So an analogy that I like to use is that you can think of a list as a train, okay? A train. And each train car is allowed to contain stuff, right? So you can have the first train car and it contains a numeric vector. The second train car contains a character vector. Third train car contains an integer vector. And when you use single square brackets, it's going to return back the train cars, okay? The train cars. So you can say single square bracket 4:6 will return train cars 4, 5, and 6. Okay. Whereas double square bracket, okay, you're gonna look inside train car number 5, and you're gonna take the object out of train car number 5. Okay. So double square bracket is similar to this, except it only returns you a single square bracket and it extracts the pieces, the elements from that list. Okay. So you need the double square bracket when you are working with a list. So let me just show you an example. Here is a list. There are 2 elements in it. There's train car X, which contains the vector 1, 2, 3, 4. And then there's train car Y, which contains a vector 9, 8, 7, 6. If you ask for a double square bracket 1, it says, look at the first train car and give me the object inside. The object inside is the vector 1, 2, 3, 4. Double square bracket with a Y inside there says, look at the train car Y and give me the object inside. That's going to be the vector 9, 8, 7, 6. So double square bracket extracts the element inside the train car inside the list object. If I use a single square bracket here, I can say, give me back train car Y, train car X, and another copy of train car X. And so now I get a new list. This list is length 3, and each of those train cars contain, their respective objects in it. So I've got a list of length 3. Okay. Now, you can't do this you can't ask for multiple. You can't extract multiple cars, right? So you can't say double square bracket, give me Y and X. Okay, so this breaks. Why? The reason why it breaks is because R doesn't know if you're going to be trying to combine vectors or objects of different type, right? Because inside a list, you can basically put in any object. So technically, I could combine this vector Y and this vector X, 9876 and 1234. That wouldn't be a problem. But inside a list, you can actually store other things like a function. So inside the train car, you could put a function inside. Inside a train car, you could put a data frame. Inside a train car, you could put another list. And so what if I have this atomic vector 9876 and the object inside of X, the train car X is a function? How would I combine those two things? You can't. Okay. So rather than just trying to figure out what are all the different possibilities that could happen, R just says, if you're going to ask me to extract out the actual object inside a train car, you're not allowed to combine it with other things. So if you try to do double square brackets with multiple things in there, it comes back and gives you an error. It says subscript out of bounds. It's actually the way it's set up is it's doing trying to do recursive subsetting and just doesn't allow that. Okay, so yes, there is something called recursive subsetting, and and this is where it gets a little bit wonky. But here, okay, list A. So the top level structure is A, and it's a list, and it's a list of 2. There's element X and there's element Y. Okay, so I've got a train. There's 2 cars in my train, element X and element Y. Except inside train Y, train car Y, what do I have? I have another list. I have a list inside of a list, okay? And so that list inside of Y has elements X and Z. X has the character A, and there's like a little train inside there. So train car X inside here has character A, and train car Z has the letter B inside. Okay, so you can do this. You can do double square bracket Y. So at the top level, you've got these 2. Maybe a little diagram. Right. So this is train car X, and we've got 1, 2, 3, 4 in here. All right. And over here is train car Y, and inside Y, I've got another list, X containing X and Z. And X has A, and this has B. Okay, so here, and then this over here is A. All right, so if I do A double square bracket Y, double square bracket X, what is it referring to? It's saying look inside Y, and within Y, look for X, right? And this is going to be the character A, right? And similarly, this is where you could do recursive subsetting. And if you say look for Y, then look for X, this is what's going on. Okay, so these 2 things are equivalent. So this statement up here is equivalent to this statement. All right. All right, so let's take a look at this. So what is structure? Structure just basically lists off the basically gives you basically this diagram here, okay? Except just kind of in text form. Structure gives you the diagram, how the list is structured in text form here. Okay, so what is D? D is a list of 3. It's basically 3 train cars. Train car A, train car B, train car C. There's no lists nested inside a list. It's just numeric vector, logical vector, character vector. So is it helpful for me to draw a little the diagram? Okay, so here I've got, I want to make sure I don't lose all of my time. All right, so here's train car A, train car B, train car C. This has the character A. This has true, true, false. And this has 1, 2, 3. All right, so what do we get? Single square bracket. Single square bracket returns the train car itself. The train car itself. So this is going to be list type. Double square bracket gives you the contents. Okay, so D single square bracket will return back this. D double square bracket returns back the contents. Okay, so this is going to be a list, and this will be a double type vector. So when you ask what's the type of this thing, it's a list. It's giving you back the train car itself, and over here it's giving you the vector itself. And I want to make sure that distinction between the single square bracket and the double square bracket is clear to everybody. Okay, so here's another list, L1. There's no names this time. Just has cars 1, 2, 3. Okay, integer, character, integer. Single square bracket gives you the list. Double square bracket gives you a vector. Okay, that's the difference there. And the way it denotes this, okay, even though there's no names, you can tell that the contents of L1, single square bracket, is a list because it's preceded by this double square bracket business. Double square bracket here tells us that this is the contents of a list. Whereas over here, there's no double square bracket in the output. It's just a single square bracket, so that indicates to you that it's a vector. So if we wanted to subset this, why am I getting back nothing? All right. So here I'm basically asking, give me, remember, L1 single square bracket is a list. It's the first train car. And I'm asking, hey, give me the second element of that list. Well, there's no second element. There's nothing there. So we get back a null. Here, I can say, okay, open up that first train car. All right, double square bracket. Now I've got a vector, and I say, what's the second element in that vector? The second element in that vector is the number 2. Okay, I can do recursive subsetting, 1, 2. This is equivalent to saying, look at the contents inside that first train car, which is a vector. Give me the second element inside that vector, and the second element is 2. So this is going to work. Okay, a list inside a list, and again, this time we have no labels here. All right, so again, maybe a little diagram will help, but again, there's no labels here. Top level, we have a list of 3. Okay, so this one has the letters D, E, F, G. We've got 10, 20, 30. And inside here, I've got a list inside here. All right, so this is 1, 2 through 8, I think, and this is A, B, C, and this is 5, 4, 3, and so on and so forth. Okay, so we've got these values. So when we ask, okay, what is the first element of L2? Okay, the first element of L2 is this train car, all right? And so we've got this double square bracket, and within there, we've got, so it's a train car, and inside that I've got a train, okay? And I've got 1 through 8, A, B, C, D, and 5, 4, 3, 2. Single square bracket, okay? And so this is the structure of this says it's a list of 1, and within that list of 1, again, we're getting back this entire train car, the entire list, and within that is another train. It is a list. So this is a list, and inside that is a list. If I do double square bracket, then we're going to get back the contents, okay? So L2 double square bracket will just give me back this, okay? Will give me back these, will give me back the list 1, 2, 3, A, B, C, 5, 4, 3. And we'll get back a list. This is a list of 3. And so now here are all of the differences, okay, when we subset. This says, give me back the first element of the contents in there, all right? So what's that? That's going to be this. So this is a list, okay? This says, try to give me the second element when you just subset it to the first list element. Well, there's nothing there, okay? Here, if I say, okay, look at the contents of that, that's going to be the vector itself inside here. So when you do L2 double 1, double 1, this will be the actual vector. Okay, and then from there you can say, okay, I want the second element within that vector. And we'll get that, number 2. All right. So if you can understand the differences between what's going on here and what's going down here, then I think you've got a solid handle. And if it doesn't make sense, if you're looking at this and it doesn't make sense, you can't even read what's going on, take the time to make sure you are able to read this, okay? It's kind of one of those things where it's just with enough time and exposure, it will start to make sense. All right, and as you know, people are like, how do I study for this class? Well, one thing you can do is you can just start writing gibberish, okay? So you've got this, we've created this vector, right? So take this code, put it in your thing, create this list, do this, all right, create that list, all right? And so here I've got L2, whoops. Is that not a, okay. So you've got this, and then you can just start asking, okay, what's going to happen? Just put in double square bracket 2. What am I going to get? Okay, what's going to happen if I do this? Okay, what will value I get? I'll get 30, right? You can ask, okay, what will happen if I do this? Okay, I'm going to get a list null. Okay, what's going to happen if I do this? I'm going to get the list with that. I can ask, I can do stuff like this. And now I get the vector, and you can just kind of try and play around with it and see if you can predict what is it going to output. When is it going to produce this double square bracket business? When is it only going to produce a single square bracket? Just do little self-tests there. You can do double square brackets on atomic vectors itself, and when you do that, basically it drops the name. So here I've got a named vector. Normally, single square bracket will preserve the name. A double square bracket on an atomic vector will drop the name. Let me give you your second view quiz answer for today. Second view quiz answer today is D, D as in dog. D as in dog. There was a question, why was this one null? Okay, so here, this is a single square bracket here is going to give me back a list. It's going to give me back a list of just one element. Okay. And then now if I say, what is the third element of this list of length 1? Okay, there's no third element. It's a list of length 1. There's no third element. There's only one element there. Okay, we're not asking what's the contents. What's the third element of the contents? We're asking what's the third element of this list of length 1. That's why there's nothing there. Okay, so here I've got a length 3 vector. X is length 3. And here if I say, well, what is the fifth element of X? Well, that's a missing value. If you do a double square bracket and you ask what's the fifth element, extract the fifth element of this thing, then you get an error. You get a subscript out of bounds. Okay. If you put a null here, you get a 0 length vector. If you put null in double square brackets, you get an error. Okay. Attempt to select less than 1. So these are just some of the errors that you might encounter when subsetting with single or double square brackets. So let's take a look at this list of length 3. Single square bracket on something out of bounds. So this is length 3. If I say single square bracket on list the fourth, it just gives me back a null. If I say extract out double square bracket on something for 4, then I get subscript out of bounds. So this is a very common error. Subscript out of bounds is a very common error. This is not an error. This gives you back a list, but it's a null list. But here, subscript out of bounds is a common error, especially in loops, especially when you have your ending condition, like while I is equal to less than something. Sometimes it's easy to go out of the bounds here. Okay. Similar kind of thing when trying to put in a null. Okay. Subset with null, you get an empty list. Subset, trying to extract out of the null, you're not allowed to do that. Let's talk about subsetting matrices and arrays. So moving on from one-dimensional now to two-dimensional structures. Okay. With subsetting a matrix, you can give it multiple vectors. This is probably the most common method, but you can also subset with a single vector or with another matrix, a subset of matrix with a matrix, which I would say is the least common method, but it can be done. So here is a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. And I gave the columns the names A, B, C. I didn't give the rows any names. I got the first row, second row, and third row here.
Mom, can I want?
So if you want to pull out the first and second rows, you can do
like I did.
so, the first and second rows, you can say A subscript 1:2, and it would return back the first and second rows of this matrix. You can use a true false vector. So true, false, true will give you back the first and third rows. Okay, and here we're saying I want the columns B and A in that order. So I get the first and third row in columns B and A. And so this gives me back, we are subsetting this thing to that, okay? You can say, I don't want any rows, 0 rows, and I want everything but the second column. And here we get back no elements of the matrix, but we do get back the column headings of A and C, the column names. When you subset a matrix, by default, it's going to simplify its output. All right. So when you ask, is this matrix, is it a vector? A is not a vector, right? A is a matrix. But if you just say, give me the first row, it's not a one row matrix of one row. It becomes a vector, right? So if you look at this, if you say, give me the first row, it's not a 1x3 matrix. It's just a vector of length 3. So if you say is vector A 1 comma, that is a vector. Are the names returned as a, again, the names are not returned as a vector. The names are attributes And so you have the attributes list, and the names are stored in the attributes list. They are not inside the attributes list. The names are a vector in the list element names, but they're not returned as a vector. They're part of the attributes. The vector is just 147. The names are stored in the attributes list. Okay. Here is a 5x5 matrix with the letters A through Y. And you can kind of just treat this. You can subset using without a comma, okay? So here I said, give me the first row, comma, all the columns. You don't have to put in a comma. Here I just give it a single vector, and I say, give me the 8th and 9th elements. Okay, so the way R labels these things is it goes down the columns. The 8th element is H, the 9th element is I. So it's going to give you back H and I when you ask for the 8th and 9th element. Okay, so again, they are in column major order. They just kind of list these off as 1 through 25. You can think of it just as an atomic vector of length 25, but rearranged in this 5x5 grid. So you ask for the 8th and 9th elements, and there you get the 8 letters H and I. And finally, let's talk about subsetting a matrix with a matrix, okay? When you subset a matrix with a matrix, basically you're going to give it coordinates. So here I have a matrix and it's 2-dimensional, and I can basically say I want elements based on, I want the element in the first row, 5th column. I want the element in the 3rd row, 1st column. I want the element in the 2nd row, 3rd column, okay? So 1st row, 5th column is U. 3rd row, 1st column, okay, which is what I have here, is going to be C. 2nd row, 3rd column will be L. And then the last one, 1st column is A. So you can get these back, and you're basically giving it coordinates of which element you want. So this is another way to do it, okay? And so if you have like a 3-dimensional array, you can subset it with a matrix of 3 columns, giving it a coordinate for the first position, first, 2nd coordinate, and 3rd coordinate, and so on and so forth. So here I'm selecting it with a matrix with 2 columns, giving it the coordinates that I want of the element, giving the coordinates of the elements that I want. So that's another way to subset a matrix. I would say this is probably the least common method for choosing elements. So, number of columns. So when you define a matrix, I'm just giving it a vector, and normally it fills out column wise, okay? But here I'm saying fill it out by row and arrange it so that the resulting matrix has 2 columns. That's all I'm saying. So then this is kind of what the matrix will look like. So here's an element. I've got a 3-dimensional array, 2 rows, 3 columns, 2 layers. And so I can say, give me back 1st row, 2nd column, 1st layer. 1st row, 2nd column, 1st layer is 3. 2nd row, 3rd column, 2nd layer. 2nd row, 3rd column, 2nd layer is the element 12. And so we can do that as well. We can work with data frames and subset data frames as well. And I'm probably going to run out of time before I get through all of these slides. So please make sure you take some time this weekend to review the slides. I'm going to run out of time to cover. And let me go ahead and give you your 3rd view quiz answer today. 3rd view quiz answer today is E. E as an elephant. E as an elephant is your 3rd view quiz answer. I'm just going to keep going. I'll run out of time. You can look at the remaining slides on your own. So a data frame, again, is stored internally as a list. So the way we subset lists with all of the double square brackets and the $ signs and all of that will work for subsetting a data frame. A data frame is also structured in this 2-dimensional structure, much like a matrix. So you can also subset the way you would kind of subset a matrix. So here's this simple data frame where I've got columns X, Y, and Z. And what am I doing? I'm creating a logical vector I'm saying take the elements of y, divide by 2, and if the remainder is equal to 0, meaning if it's an even number, if the element in y is an even number, then return true. So we're going to go through the column y. Which elements in y are even? This first row, this third row, 4 and 2 are even. And so we're going to get back those rows. Okay, 1, 4a, 3, 2c. Okay, so this is a logical statement. It's going to be trues and falses. It's preceded by a comma, so it just says, give me the rows that match that true false statement. Give me all of the columns. That's what we've got going on there. If you want, you can just subset a data frame the way you would subset a list. So here I'm just saying, give me back elements X and Z. And as far as a data frame goes, the elements of a list are the column names. So we're going to just get back column Z, column X and column Z. You can subset the data frame like a matrix. So the only difference between this and this is that here I put a comma here. So this says, give me back all of the rows, give me the columns X and Z, okay? Give me columns X and Z. And so this result and this result are the same, but notice here I'm subsetting like a list, giving it the names in the list, and over here I'm giving it the names of columns, which as far as a data frame goes is pretty much the same thing. But there's a comma here, there's not over here. When we do this with the rows though, we put the row numbers before the comma. Okay, and so here I'm going to say, give me back row 1 and row 3, and there's a comma, right? So I get back the first row and I get back the third row. Okay, if I didn't put in that comma, what happens? Okay, if I don't put in the comma, I get back the first column and the third column. Okay, so if you want to select rows, you need to include the comma, because otherwise, when you subset a list and you say, give me back the first and third elements of the list, the data frame is structured where the list elements are columns. So when you do this without the comma, you're going to get the first column X, then the third column Z. I hope that's clear, the difference between what's happening here with the comma and what's happening here. I believe I gave the second answer for the quiz. I think so. Did I? I did, right? I gave you all 3 view quiz answers by now. Okay. So when you a subset, okay, with a matrix, it's going to simplify, and whereas when you subset with a data frame, it will not. Okay, so when you do DF, and I'm sorry, so when you subset the data frame, and you just say, give me back column X, it's going to return a data frame. And over here, when you subset the data frame and you just say comma X, it's going to simplify a single column. It's going to simplify down to a vector, right? This is a little bit strange. It's one of these behaviors. When you use the tidyverse and work with tibbles, it eliminates this behavior. It's always going to kind of behave the way you want it to behave. Or I don't know. It's the behavior is a little bit more consistent. Anytime you use $$ subsetting, so if you say, give me back column X by doing df $X, the way you would subset a matrix, subset a list, give me the X column, then it becomes a vector. I'm gonna just skip over all of this simplifying versus preserving. I just want you to kind of make sure you take a little bit of time this weekend to go over some of this stuff, and some of the stuff applies to factors and all of these other things. Let me just go over a couple examples here. So here is MT cars. This is just a data frame that exists inside the computer, motor trend cars, and it's got all of these old vehicles in there. And it's got the columns, miles per gallon, cylinders, displacement, horsepower. I don't know what all of these things are, weight and something. What happened here? I get an error. I said, I want the cars where the number of cylinders is less than or equal to 5, right? So that your engine can have 4 cylinders, 6 cylinders, 8 cylinders. And I'm saying I want the cars where the number of cylinders is less than 5, less than or equal to 5. And when I do this, I get an error. I said it says undefined column selected. Okay. The problem is that I left off the comma. Okay. So when I do this empty cars cylinders less than or equal to 5, I can get like false, false, true, false, 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 true, true, and things like that. And again, it's like I'm providing a true false vector without a comma. So it's assuming I'm trying to select columns based on this true false vector. And so if like the 13th element is true and I don't have 13 columns, this is why it's giving me an error that says undefined columns are being selected. Okay, so I have to put in that comma. What's happening here? I'm saying I want so now I have the column, comma, and I said I want the cars with 4 cylinders or 6 cylinders, 4 or 6. But I'm getting back cars with 6 cylinders, 4 cylinders, and look, I'm still getting 8 cylinders. I'm not getting back the answer that I want. Okay, so when you say order of operation, what do you mean? What's happening? So what's happening is, okay, this gets evaluated. Empty cars cylinders equals 4. That's going to be false, false, true for the 4, false, 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 true, true, so on and so forth. What is this? I have an OR 6 here. This OR thing is going to coerce anything that's not a 0 to a true. Okay, so I've got this true false vector, which evaluated correctly, or true, okay, because the 6 gets coerced to a true. And so basically, I'm just saying, give me back every single row. So if I want this to work, what I have to do is I have to do empty cars cylinders equals 4 or empty car cylinders equals 6. And that will subset correctly. That will subset correctly. Okay, anyway, so I'm out of time and you can try this out and go over this, but take a look at it this weekend. Other than that, have a great weekend and we'll see you guys on Monday. So we'll see you guys later. Thank you.